Okay, today we're going to graph linear inequalities again, just a little bit trickier. Okay, the first one is example 0 because it's exactly like what we did yesterday. Okay, so we're going to go ahead and graph the boundary line first. This is less than or equal to. Remember, because of the equals, it's going to be a solid line. Okay, slope-intercept start at the positive 3, up 1 over 2. Go ahead and make my line. Was this solid? Solid. Okay, we can check a point. What should we check? 0, 0? Let's check 0, 0. Okay, 0 is less than half of 0 plus 3. If in your head you're like, I already know half of 0 is 0, you could skip to 0 plus 3. So is 0 less than or equal to 3? Yes, it is. So just make sure you shade the 0, 0 side. Okay, hopefully that is quick and easy. Okay, now the next two are going to be in standard form, which means you have to be a little bit more careful when you solve them. Okay, I can already tell this is going to be a dashed line, but it's not in slope-intercept form. It doesn't start with the y, so I need to solve it first. So I'm going to go ahead and solve this equation for y. So I'm going to move the 2x over. Bring down the 5y. 5 plus 2x, no, let's make it 2x plus 5. Divide everything by 5. Okay, now we can do the boundary line. What was it dashed? Okay, the y-intercept's 1. We're going to go up 2 over 5. And we're going to make it a dash line. Okay, not terrible, right? Okay, now I am going to check 0, 0. Okay, now there's options here. I'm going to show you your two options. We can plug into this equation like we normally do. That will work. The only problem with plugging in here is if we make a mistake in solving, we might get a false result. And because if we divide it by a negative, things get messed up, so we could also get a false result. You could also go back and plug it in the original equation. I'm going to do it both ways. You don't need to do it both ways. You need to pick a way and stick with it. Actually, let me plug it in the original first. So if I plug 0, 0 in the original equation, I get negative 2 times 0 plus 5 times 0 is greater than 5. And I'm like, 0 plus 0 is greater than 5? Nope. And based on that, I know I'm not shading this. Or I can plug it in down here. I'll get 0 is greater than 2/5 of 0 plus 1. 0 is greater than 0 plus 1. 0 is greater than 1. Nope, still not true. So it doesn't matter which one you plug it into, you're going to get the same result. Whichever one looks easier, plug it into that one. Because you're used to this, some of you like this one, but if you plug it in here, there's no fractions, so either way is fine. Okay, then last example is going to give you a chance to see when it gets a little tricky when you solve and when you have to be extra careful. Okay, it's not in slope-intercept form, so let's go ahead and solve it. Plus 4x. Okay, that cancels. I bring down the negative 2y. 4x plus 6 because they're not like terms. And now I'm going to divide by negative 2. Okay, now here is where the trouble sometimes comes. Because we divided by a negative on both sides of this inequality, remember this symbol has to switch. Now it switches to greater or equal to. And I get negative 2x and I get negative 3. Okay, let's go ahead and graph it and then we'll see what we get. Okay, so negative 3 is the y-intercept. The slope's down 2 over 1. Is this solid? This is solid because it has an equal sign. Okay, I am going to check 0, 0. Now this problem is an example of where sometimes plugging in the original would be safer. If I plug it in the original, it will for sure tell me the correct side to shade. Now, if I plug it in here, assuming I remembered to switch the inequality, it will give me a correct result. If I forgot to switch the inequality, it's going to give me a false result. It's going to mess up my problem. So it's safer to check it here, but as long as you're careful and confident, you can check it right here. Okay, here. If I plug it in right here, I could do it in my here. 4 times 0, that's 0. Minus 0, is that less than 6? Yes. If I plug it in down here, 0 is greater or equal to negative 2 times 0, which is 0, minus 3. 0 is greater or equal to 0 minus 3. Yes. So no matter where I plug it in, I get yes. If you're worried you're going to make a mistake or forget to switch this, then plug it into the original. Okay, so what am I shading? I'm shading the side with the 0, 0. Okay, try the practice problems. They're mixed practice. Check your answers when you're done.